Project 1.5 Counting Circuit. This project has 8 stages. The project introduces various chips known as the NAND Gate 4011, Decade Counter, which is the 4017, Binary Counting Decoder, or the BCD, which is the 4510, and finally the decoder, which is the 4511. Furthermore, a 7-segment display was established. The first circuit made in this 8-part series was the analog input. The momentary PBNO at the beginning of the circuit is the on/off switch of the final circuit. By using the pull-down resistor, when the PBNO is pressed, it will turn on. This circuit uses a pull-up resistor because the inputs need to be high before pressing the PBNO, and then they become low, allowing the LED to turn off. Next, the NAND gate oscillator, known as the NGO, has 2 parts. Firstly, the RC1. When the PBNO is pressed, the LED will turn on for a few seconds before turning back off. This happens because the capacitor releases energy into the LED, and the 1 megaohm resistor allows for very little amounts of current to flow through to ground, making the LED turn on for a certain period of time. Secondly, the RC2 uses the same components as the RC1, except it adds a 470 ohm resistor, a 1 megaohm resistor, and contains a 104 capacitor which controls the frequency. Additionally, an analog input and a digital output is used in the circuit. The analog part happens when the capacitor releases energy, while the digital part happens when the LEDs go high, then low. Hence, the circuit has a duty of 49%. The following phase is to add a 4017 chip to the circuit alongside an LED bar graph, making the decade counter. It consists of 10 outputs. The 14th pin generates a clock signal, while the 12th pin is the divide by 10 pin. The divide by 10 pin divides a clock signal by 10 to make it readable to the human eye. On top of this, a 4510 is added to the circuit. It has 4 outputs connecting to the 4 LEDs. The 12th pin connects to the clock signal from the 4017 to the 4510. The 10th pin is an up/down pin connected to a switch. The 9th pin is the reset, which is connected to a PBNO. This circuit uses binary to count up/down. The chip gets a signal in decimal form and translates it to binary as displayed using the 4 LEDs. Before creating the final part of the circuit prototype, the 4511 chip must be added. The chip has 16 pins. It has 4 inputs that are connected to the previous chip's outputs. It has outputs ranging from the letters A to G. This will be important when adding the 7-segment display. The counting circuit prototype's final step is adding a 7-segment display alongside 7 470 ohm resistors. The 7-segment display has 10 pins. 7 of its pins are labeled letters between A and G. The display has 7 built-in LEDs. Each letter is connected to the corresponding letter on the 4511 using 470 ohm resistors. The resistor ensures that the display does not short and that the LEDs are not too bright. The numbers are displayed in Arabic numerals. After making the prototype, a custom PCB was made. It goes on or off depending on what side an SPDT is switched to. It starts when the PBNO is pressed. It counts up or down depending on which side the second SPDT is switched to. Thank you for listening.